So what if I were to tell you there was one molecule out there that could make quantifiable changes in soil health, allow nutrients to be delivered and applied more efficiently, and help combat pest resistance through new crop protection modes of action and AIs? Well, I'd be telling you a complete bald-faced lie. There's no one molecule that does all that. That's crazy. So my name's Trey Cutts. I'm VP of Commercial Ag Science for Tidal Grow AgriScience. And what I want to talk to you today about is our core technology of the molecule chitosan. So what is chitosan? Well, it's a polymer, but it has the benefit of being naturally derived from nature. So chitin, which is essentially the polysaccharide that makes up crab shells, insect exoskeletons, most abundant polymer in nature behind cellulose. But you're able to extract it and put it through a process where you essentially end up with base chemistry that's a monomer with different characteristics. So yes, chitosan as a molecule can achieve all this, but the outcomes really depend on how it's manufactured, characterized, and bioengineered. And chitosan's not new in the ag industry either, right? I think lots of people have tried to crack the code of chitosan because there are such great benefits and versatile benefits from crop protection to biostimulant, etc. But today there's really been no way to manufacture chitosan, one, at scale that can enter industries like agriculture and bring something cost effective, but two, really control the process to produce something that's on spec that's going to achieve the outcome you want. The molecule orientation really matters. Think of it like silicone, right? If you were just to say, well, I've got a silicone product, here you go. Well, is that a oven mitt? Is it going into a binder and hair gel? What is it doing? It depends on how you orient that base molecule for that outcome. So not all chitosan is created equal. It really depends on the molecular weight of chitosan, how many acetyl groups are on it. So chitosan really depends on the molecular weight, how many acetyl groups are on that monomer chain. And when you can precisely manufacture and control for that, you now unlock the potential of what chitosan can do. Also, chitosan today is in very niche industries because it's very expensive and very wasteful to produce. It's something like 1 ton of chitosan per 7 tons of toxic waste. What Tidal Grow and our parent company have pioneered is a green, zero waste manufacturing method. So normally you think green and more expensive. Actually, it's reduced the COGS of chitosan manufacturing to allow us to enter agriculture in a cost-effective way. We also have a proprietary way to control for that chitosan manufacturing so that we're producing on spec and you get the molecule that you need. And we're also domestically produced, made in the USA. So what does this look like to develop, say, a crop protection product out of chitosan? So you can see we'll get a number of different chitosan specs, right, coming out of our manufacturing. They could be used from anything from wastewater treatment to textiles and materials or agriculture. So we'll take chitosan characters out of our manufacturing library. We've characterized over 10,000 so far. Then they'll come into the Tidal Grow dedicated science team to then start to look for different use cases for chitosan. This is an example of fusarium control on agar-plate. And we start to narrow down what molecule do we need to bring an effective formulation to market. But it doesn't stop there. If you mess up that formulation, either with the wrong molecule or wrong inert, you could actually backfire and create the opposite effect of what you're looking for. Like here, promoting growth of fusarium. You can create a carbon source for it. So this really matters when you're trying to approach the market with something as serious as crop protection. And then we work also to get targeted efficacy with the most precise formulation possible to make sure that we're meeting farmers where they are with the normal use rates and fit into existing spray programs, and most importantly, be cost effective. And what you can achieve with that is actually quite stunning. GenMax is our precisely formulated seed treatment. And here we're just showing basically a return on investment. Hidden behind this is the nematode control or the soil-borne disease control, but really getting a really high win rate, really high ROIs. And that didn't happen by accident by taking an unformulated chitosan and putting it on seed. Other formulations we've designed to target foliar diseases and bring new modes of action to crop protection. Here you can see tar spot control, not only reducing severity, but also giving you that yield bump, the miracle molecule, right? But it's also able to fit in with existing programs. We don't want to create another case of resistance. We're trying to combat that. So we do see really good results when going in with your existing program. Also in potatoes is another great example where we're controlling early blight as well. Again, something that goes in with an existing spray program, something that delivers a strong ROI and is able to meet growers where they're at and solve real problems. So we need new modes of action out there, and we need new ways to deliver crop protection and nutrients. So how do we do that? Is it the next miracle molecule? No, we believe it's a platform molecule such as chitosan that we can now unlock the different chemistry and use cases to tackle some of these issues. There is no silver bullet, but there might be a silver platform. And today, Tidal Vision, we are across several industries, which just shows the strength of our science, our molecular design, and our scalability of production, being in wastewater treatment, materials, and agriculture. Thank you very much.